Okay, this algorithm challenge stems from Colt Steele's Udemy course on algorithms and data structures. This is the first challenge you get when you're done watching all the videos in the recursive section. So the algorithm challenge is to write a function called power, which accepts a base and an exponent. The function should return the power of the base to the exponent. This function should mimic the functionality of MathPow. Do not worry about negative bases and exponents. So down here you see what this function should return. So if you have the first argument is 2 and the second argument is 3, so in essence if you have a base of 2 to the exponent of 3, it should return 8. If you have a base of 2 to the exponent of 0, it should return 1. If you have a base of 2 to the exponent of 4, it should return 16. So one of the first things I did is write an if statement and check if num2, essentially if num2, which is the exponent, is 0, because anything raised to the power of 0 is always 1. So let's write that if statement now. So if num2 is equal to 0, this should return 1. Okay, so the next thing I wrote is we want to create the base case. Because this is going to be a recursive function, we want it to meet the base case requirements so it doesn't run into an infinite loop. And if you do receive that, you'll probably get an error saying the call stack was exceeded. So this recursive function needs to have some sort of base case so it stops calling itself. In this case, I wrote this if statement: if num2 is equal to 1, it should return num1. And I'll explain that in a little bit. So in order for this function to successfully satisfy this if statement, num2 needs to be decreased. So we want num2 to be decreased every time this function calls itself, and that is what these two little minus signs do. They subtract it by 1, or they subtract num2 by 1. And then we want to do the recursive part of this function, which is return num2 times, and we want to make sure this function calls itself. Return num2 times power num1 times num2. Okay, so here we have the function calling itself, and eventually it'll satisfy one of these two. If it doesn't satisfy this base case, so if num2 is 0 from the get-go, it'll stop here. If not, this function will keep calling itself until num2 is 1, and then it'll return num1. And here is where we subtract num2, so it eventually meets this if statement requirement. And here is just where we call itself the recursive part of this function. So let's find out if we got the correct answer. Here we have, as you can see here, in the course you get a section where kind of a text editor, I guess, and as you can see, I already pre-filled in my code here, and it's telling me that well done, your solution is correct. So that's awesome. The code is working perfectly. It meets the requirement. So what I also wanted to do is explain more in detail what is going on. So for example, if we called our power function, so here is our power function, and gave it the parameters of 2 and 3, so 2 being the base and 3 being the exponent. So let's kind of walk through it. So we're giving the parameter of num1 is going to be 2, so num1 is going to be 2, and num2 is going to be 3. Okay, so our exponent is going to be 3. Okay, if num2 is equal to 0, so is our exponent 0? It's not, so it's going to skip this if statement. Then it's gonna say if num2 is equal to 1, is our exponent equal to 1 right now? It is not. So it's gonna skip this if statement. Then it's gonna subtract it. And it's gonna subtract 1 from num2. Remember, num2 is our exponent, which right now is 3. So it's gonna call this function. Then it's gonna reach this on line 13. It's gonna go return num2, and I have this line here, return num2 times the power of 2 and 2. So the only thing that really changed is we subtracted 1 from this 3 up here. And again, we're calling the power function again. So now we're going to call it again. So power 2, 2. Is num2 right now 0? It's not. So it's going to skip that if statement. Okay, is num2 equal to 1? It's not. So it's going to skip that if statement. Then it's going to subtract 1. Okay. And then it's going to call, we reach line 13, return num2 times power num minus 1. Okay, so now that's where we get this line. Return 2 times power 2 power with our base of 2 and our exponent of 1. Okay, so then we call our function again. Okay, so is num2 equal to 0? Okay, no, it's 1 right now. So it's going to skip that if statement. Is num2 equal to 1? If num2 is equal to 1, return num1. Okay, so our exponent is at this point equal to 1, so it's going to return num1. So it's going to return our base. So at this point, we actually have returned something. It's met our base case. It met our base case, so the function is going to stop calling itself. Okay, so we have 1, 2, 3 functions waiting to be returned at this point. Okay, so we know that this function right here, power 2 and 1, has returned num1. So it actually returned a number now. So now really what we're looking at is we're gonna erase this. And remember, this function successfully returned a number, which was 2. So now it's returned 2 times 2. So now this function, we can now return this function. Return 2 times 2, which is equal to 4. Okay, so this function has now returned the value of 4. So we're going to erase this, and we're going to put 4 in the place of power 2 and 2 just to show that it returned the number 4. Okay, so now this is the function that's left waiting for us to return a number. So in this case, we have returned 2. Let me clean that up. Return 2 times 4, which is equal to 8. So we returned the number 8. And that is how this recursive function works. If you have any questions, let me know, leave a comment or message me.